Hello, Acute Angels. This is Teacher Anna, and welcome to another Matinic episode. Today, we will talk about permutation. Are you ready? Well, at the end of this lesson, you are expected to illustrates the permutation of objects and solves problems involving permutations. So, what do we mean by permutation? Permutation is a collection or a combination of objects from a set where the order or the arrangement of the chosen objects does matter. In other words, a permutation is an ordered combination. But why an ordered combination? Well, in English, we use the word combination loosely, without thinking if the order of things is important. For example, my fruit salad is a combination of apples, grapes, and bananas. And we also have the combination to the shape is 4, 7, 2. If we dig deeper, in the sentence, my fruit salad is a combination of apples, grapes, and bananas, we don't care what order the fruits are in. They could also be bananas, grapes, and apples, or grapes, apples, and bananas. It's the same fruit salad. While for this sentence, the combination to the shape is 4, 7, 2. Now, we do care about the order. 7, 2, 4 won't work, nor will 2, 4, 7. It has to be exactly 4, 7, 2. So in mathematics, we use more precise language. When the order doesn't matter, it is a combination. But when the order does matter, it is a permutation. Now, let's see some examples. How many ways can we arrange 3 students in a line for a picture? Let's say those 3 students are Anna, Ella, and Ross. Using an illustration, the first arrangement could be like this: Anna, Ella, and Ross. For the next one, we have Anna, Ross, and Ella. We also have Ella, Anna, and Ross. Also, we have Ella, Ross, and Anna. The next one is Ross, Ella, and Anna. And lastly, we have Ross, Anna, and Ella. By counting, we can conclude that there are 6 ways to arrange 3 students in a line for a picture. But what if instead of 3 students, we have 7? How many ways can we arrange 7 students in a line for a picture? Are we going to do the same? Let's say those students are represented by A, B, C, D, E, F, G. Here are the possible arrangement: A, B, C, D, E, F, G. The next one is A, B, C, D, E, G, F. The third arrangement could be A, B, C, D, G, E, F. The fourth one could be A, B, C, D, G, F, E. And the list goes on and on, which is quite impossible for us to know in a short period of time if how many arrangements can be made to them because we are using the listing method. But wait, we have another method to solve for it. In general, the number of distinct permutations of n objects is n factorial. or in symbol, is n with an exclamation point. Since it's only asking about the number of ways, not the list, we can use this formula, n factorial. But what is factorial? Factorial means to multiply a series of descending natural numbers, which means we are going to stop multiplying if we reach 1. For example, 4 factorial, and the numbers before 4 are 3, 2, and 1. And we are going to multiply all of them. 4 times 3 times 2 times 1, and the answer is 24. Another example is 3 factorial. We have 3 times 2 times 1, which is equal to 6. And for 2 factorial, we have 2 times 1, which is equal to 2. And for 1 factorial, we have 1, since it is the last number. But we have a special case, 0 factorial. 0 factorial is equal to 1, just as 1 is equal to 1. Since it is all about arrangement, if we have nothing, that's already an arrangement, so we consider it as 1. Again, 0 factorial is equal to 1. So, going back to the question a while back, how many ways can we arrange 7 students in a line for a picture? We can now identify the number of ways using the formula n factorial. N is equal to the number of objects, which in the given problem is equal to 7. And substituting it to the given formula n factorial, we have 7 factorial. And 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And 7 factorial now is equal to 5040. Therefore, there are 5040 ways to arrange 7 students in a line for a picture. Now, let's try to answer the first problem we solved earlier. How many ways can we arrange 3 students in a line for a picture? Using illustrations and listing method, we determined that we have 6 ways. But let us see if it is the same if we use the n factorial. N in the given problem is equal to 3, which is from the 3 students. So we have 3 factorial. Now, 3 factorial means 3 multiplied to 2 multiplied to 1, and that is equal to 6. Therefore, there are 6 ways to arrange 3 students in a line for a picture. So we produce the same answer. It's now up to us which method are we going to use. Is it the listing method or the use of a formula? Because at the end, we will end up on the same answer. Now, let us deepen our understanding about permutation. Aside from the fact that permutation is a collection or a combination of objects from a set where the order or the arrangement of the chosen objects does matter, permutation can be described also as n distinct objects taken R at a time, where n refers to the number of objects from which the permutation is formed, and R refers to the number of objects used to form the permutation. In symbol, we use the following notations. In short, permutation is not all about the arrangement of all the objects in a given problem. There are times we need to arrange a certain objects but we only have limited slots. Like for instance, arranging 5 photos but we only have 3 picture frame. And for that instances, we use this formula. The permutation formula, which is also known as the formula for permutation of n objects taken r at a time. The permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, wherein r is less than or equal to the value of n, and p with the quantity n and r is the number of permutations, while n is the number of objects in the set, and r is the number of choosing objects from the set. For example, in how many ways can you arrange 2 letters from the word mat? List all the possibilities. In here, we have 2 options. Either we use the permutation formula, then list all the possibilities after. Or we just list them, then count it after. But in my own opinion, I prefer to solve it first using the formula so that when listing, I already know how many arrangements should I write. So let us identify the given first. N is the number of objects, which in this case is the number of letters in the word mat, and that is equal to 4. While R is the choosing objects in the set. Out of the 4-letter word, we only need to choose 2 letters. Therefore, we have 2 as the value of R. Now, we will use the permutation formula. The number of permutation is equal to n factorial over the quantity n minus r factorial. We are now ready to substitute the value of n and r to the given formula. We have permutation of 4 objects taken 2 at a time is equal to 4 factorial over 4 minus 2 factorial. 4 minus 2 is equal to 2 factorial. And 4 factorial means 4 times 3 times 2 times 1, while 2 factorial is equal to 2 times 1. In here, since we have like terms, we can eliminate them. We cancelled out 2 times 1. And the remaining terms that we have now is 4 times 3. And 4 times 3 is equal to 12. Therefore, there are 12 ways to arrange 2 letters from the word mat. And those are MA, MT, MH, AM, AT, AH, TM, TA, TH, HM, HA, and HD. Let's have another example. How many ways can 4 books be arranged on a shelf if they can be selected from 9 books? First, let's identify the value of n and r. N is the total number of objects, and that is 9 because we have 9 books. R is the choosing objects, which in the given problem is 4 books. R is equal to 4. And again, we are going to use the permutation formula. Substituting the value of n and r to the formula, we have the permutation of 9 objects taken 4 at a time is equal to 9 factorial over 9 minus 4 factorial. 9 minus 4 is equal to 5. 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. While 5 factorial means 5 times 4 times 3 times 2 times 1. And since we have like terms, we can eliminate them. We canceled out 5 times 4 times 3 times 2 times 1. And the remaining terms that we have now are 9 times 8 times 7 times 6. And 9 times 8 times 7 times 6 is equal to 3024. Therefore, there are 3024 ways to arrange 4 books in a shelf which are selected from 9 books. Aside from the permutation of AND objects taken are at a time, we also have the special permutations. The first one is the permutation with repetition. If there are n possibilities for the first choice, then there are n possibilities for the second choice and so on, multiplying each time. And we use this formula. P is equal to n times n times n times n and so on and so forth. Or in short, we have P which is equal to n raised to r. Like in the passcode, if we are going to create 4-digit password wherein repetition is allowed, in the first digit we have 10 choices, and that includes 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Same with the second digit, third digit, and fourth digit. So if we represent it, we have 10 times 10 times 10 times 10. Or in short, we have 10 raised to 4. Let's have an example. If repetition is allowed, how many 3-digit number can be formed using 5, 6, 7, 8, and 9? In the problem, the given value of AND is 5 because we have 5 numbers which includes 5, 6, 7, 8, and 9. And the value of R is 3 because we are going to form a 3-digit number. Following the formula of P is equal to N raised to R, we have P which is equal to 5 raised to 3. And 5 raised to 3 is equal to 5 times 5 times 5, which is equal to 125. Therefore, there are 125 3-digit numbers which can be formed using the numbers 5, 6, 7, 8, and 9. Next is the distinguishable permutation. Distinguishable permutations, from the name itself, are permutations or arrangements that can be distinguished from one another. Consider all the permutations of the letters in the word Bob. Since there are 3 letters, there should be 3 factorial, which is equal to 6 different permutations. And those permutations are BOB, BBO, OBB, OBB, BBO, and BOB. Now, while there are 6 permutations, some of them are indistinguishable from each other. If you look at the permutations that are distinguishable, you only have 3, and those are BOB, OBB, and BBO. And now, to find the number of distinguishable permutations, take the total number of letters factorial, divide by the frequency of each letter factorial. In representation, we have n factorial over k sub 1 factorial, k sub 2 factorial, k sub 3 factorial, and so on and so forth until we reach k sub p factorial, wherein k sub 1 plus k sub 2 plus k sub 3 up to k sub p is equal to n. Let's have some examples. How many 7-digit number can be formed from 3, 3, 5, 5, 5, 7, 7. In the given problem, the value of n is 7. And as you notice, number 3 appears twice, and number 5 appears thrice, while number 7 appears twice. And we're going to apply this formula. In the given, 2 is the k sub 1, 3 is the k sub 2, while 2 is the value of k sub 3. Substituting these values now to the formula, we have 7 factorial over 2 factorial multiplied to 3 factorial multiplied to 2 factorial. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. 3 factorial means 3 times 2 times 1. And again, 2 factorial means 2 times 1. And since we have similar terms, we can eliminate them. We cancelled out 3 times 2 times 1. And the remaining terms that we have now are 7 times 6 times 5 times 4 over 2 times 1, which is 2, and 2 times 1, which is 2. 7 times 6 times 5 times 4 is equal to 840, while 2 times 2 is equal to 4. We now have 840 divided by 4. 840 divided by 4 is equal to 210. Therefore, there are 210 7-digit numbers that can be formed using the digits 3, 3, 5, 5, 5, 7, 7. In our next example, we need to find the number of permutations of the letters of the word aral. In the given problem, the value of n is 4 because of the letters of the word aral. Letter A, R, A, and L. And since we have some objects that appeared twice, it is still under the distinguishable permutation. K sub 1, which represents letter A, is equal to 2 because letter A appeared twice. K sub 2, which represents letter R, is equal to 1. And K sub 3, which represents letter L, is equal to 1. And again, following the distinguishable formula, we have 4 factorial over 2 factorial times 1 factorial times 1 factorial. 4 factorial means 4 times 3 times 2 times 1. And 2 factorial means 2 times 1. 1 factorial is equal to 1. And again, 1 factorial is equal to 1. As we can see, we have similar terms which we can eliminate. We cancelled out 2 times 1. The remaining terms that we have now is 4 times 3 over 1 multiplied to 1. 4 times 3 is 12, while 1 times 1 is equal to 1. We now have 12 over 1, which is equal to 12. Therefore, there are 12 distinguishable permutations of the letters from the word aral. But additional information, note that it is okay not to include the object who only occur once in the formula, because we will still come up with the same answer. 4 factorial over 2 factorial is still equal to 12. And for our last type of permutation, we have circular permutation. What is circular permutations? Circular permutations, from the name itself, are permutations or arrangements that are in circular form. And we have 2 types of circular permutation. Number 1, If n objects are to be arranged around a circle, the number of permutation of n different things is the quantity n minus 1 factorial. And for number 2, the number of permutation of n different things around a keyring and the like is the quantity n minus 1 factorial all over 2. In short, number 1 is all about circular objects which cannot be turned or flipped, like a circular table or a maypole. While the second one is all about a circular objects which can be turned or flipped, like a keyring, bracelet, and necklace. Let's look at this example. In how many ways can 4 people be seated at a round table? The value of n is 4, and the formula that we are going to use is the first one because it involves an object which cannot be turned or flipped. The quantity n minus 1 factorial. Substituting the value of n, we have 4 minus 1 factorial. 4 minus 1 is equal to 3. Therefore, we have 3 factorial. And 3 factorial means 3 times 2 times 1, which is equal to 6. Therefore, there are 6 ways for 4 people to be seated at a round table. So if we illustrate it, let's say those 4 people were represented as A, B, C, and D, and A will serve as the marking point or starting point. This will be the possible arrangement. And for the last example, in how many ways can 6 keys be arranged in a keyring? The value of n is equal to 6. And since it talks about a keyring, the formula that we are going to use is the second one, because it involves an object that can be turned or flipped. The quantity n minus 1 factorial all over 2. Now, substituting the value of n to the formula, we have 6 minus 1 factorial all over 2. 6 minus 1 is 5. And now we have 5 factorial, which means 5 times 4 times 3 times 2 times 1. And which is equal to 120. We now have 120 over 2. 120 over 2 is equal to 60. Therefore, there are 60 ways of arranging 6 keys in a keyring. And that's all you need to know about permutation. Just remember that a permutation is an ordered combination. Dear Acute Angels, you did great in watching and listening. I hope you are now confident to answer activities related to it. Again, this is Teacher Anna, and see you on another Matinique episode.